Hi mathematicians, let's talk about limits of rational functions. And I just want to review what this word rational means. Rational is any number or expression that can be expressed as p of x over q of x, where q of x is not equal to 0. Okay, so really when we see the word rational, it's kind of a fancy word for a fraction in a way. Okay, but so the first kind, sometimes you get lucky and you just get to plug in the number, right? So if we have something, let's say like this, and the first thing we always want to do is just check, can I plug in this number and let my life be easy? And so we go ahead and we plug in this number, and we get 12 minus 8 over 40 minus 36. Is that true? Yeah. Looks like we get 1. Is that, everyone think so? Do you see anything wrong with my math? No? Looks good? Okay, great. So that's the ideal situation. But then sometimes we come across something that requires us to factor and cancel. So factor and cancel is something that you're going to want to look for when you get into a situation where the denominator is 0. So for example, if we were asked the limit as x approaches 2 of x squared minus 6x plus 8, x squared minus 4, and if I were to plug in 2 here, I would quickly see that it would be a problem, right? So on top we would get 4 minus 12 plus 8. You get 4 minus 4 here. Now later on we'll see another way to deal with things like this. But for right now we're going to go back and see if we can factor and cancel. So I'm just going to rewrite this. And I'm going to go ahead and factor the top, and I'm going to factor the bottom. And I recognize the bottom as a difference of 2 squares, right? We have x squared and we have 4. So that breaks up into x plus 2 and, x minus 2, sorry. Right. The top, what do I get here? It looks like a minus 4 and a minus 2. Because I know that minus 4 times minus 2, or negative 4, excuse me, times negative 2 is positive 8, and I know negative 4x plus negative 2x makes my negative 6x. Okay, so let's see what happens here. Aha! We can cross these out. We can cancel. Fantastic. And so now, when I put in 2, I get negative 2 over 4 equals negative 1/2. And we have an answer. Okay, so factor and cancel. It's a thing. It works. It can be very helpful. I want to show you another one real quick here. This actually comes from one of the problems in your book. It's number 36. Limit as t approaches 2 of 3t squared minus 7t plus 2 over 2 minus t. Okay, so I look at this, we immediately see this is going to be a problem, right? I'm going to end up with a 0 on the bottom. So your first instinct needs to be, can I factor and cancel? And so let's go ahead and factor the top. So you get 3t, t, 2, 1. How do I know these amazing things? Well, there's only one way to make a 3. That's 3 and 1, really, right? So I just start with 3t and t. I know they have to go somewhere. There's only one way to make a 2. That's 2 and 1. That's it, right? So I can either put the 1 here and the 2 here, or the 2 here and the 1 here, right? Which one is correct? Well, I also see that I need a 7 on the inside, right? And in order to make this 7 on the inside, I need that 3 times 2 to be 6 and 1 to make 7. Okay, so these both need to be negative. That makes this positive. Negative 6t, negative 1t. All right, well, the problem is they still don't match. So what do? Well, I am going to factor out the denominator. What do you mean you're going to factor out the denominator? I am going to take out a negative 1 here and turn this into t minus 2. It's the same thing. These are equivalent expressions, right? Because if I multiply this in, I get this back. So I haven't done anything illegal. I've just changed what it looks like. I've changed the expression of that relationship. That being said, we can now cancel these. And I get 3 times 2 minus 1 over minus 1. I get 5 over minus 1. Is that correct? I think so. Minus 5. Okay, so this is about rational functions. I'm going to show another video in the second, but really this one is about factoring and canceling. Okay, but I don't want the video to get too long, so I'm going to cut now and then create a new one about using conjugates.